Good evening, children.
Good evening.
Good evening. So today we're going to take up a test on circles. And you can see the first question on your screen. Prove that the tangents drawn from an external point to the circle are equal. Yeah. So we take a circle with center O. We need to prove that tangents from an external point to the circle are equal. So let the external point be something like P. So let PT and PQ. Let PT and PQ be the tangents from the external point P to the circle. Now after this complete, please continue the proof. So we have a circle with center O, external point P. Let PT and PQ be the tangents from the external point P to the circle. Now after this, children. What should you join?
Join OT, OP, ma'am.
Okay, very good. Join OT and
OP,
OQ
OP
and
OP.
and
OP,
OP.
ma'am. OP.
And OP, correct, and OP. So join all this, correct. Now, which are the two triangles we need to take up and prove are congruent?
Triangle OTP and OQP, ma'am.
Okay, so we have to take triangles OTP and triangle
OQP, ma'am.
OQP, yeah, OQP. Tell me the three equalities.
OT equals OQ, ma'am, because
Okay,
area of same circle.
I have a question. Is PT equal to PQ?
No, ma'am, we need to prove that only, ma'am.
Yeah, correct. I like your confidence, Priyadarshini. Very good. Yes. So we need to prove that PT is equal to PQ. We need to prove that PT is equal to PQ. That's not given. That is true. It's a fact, but we have to prove that fact now. Yes. Yes, Priyadarshini, you said something.
Yes, ma'am. OT equals OQ, ma'am.
Okay, Thirunesh. Another one.
Angle OTP is equal to OQP. Radius and tangent are perpendicular to each other.
Okay, so this is 90 by the theorem. This is 90 by the theorem. So angle 1 is equal to angle 2 is equal to 90 degrees. Because by the theorem, radius and tangent at the point of contact are perpendicular to each other. And why is OT equal to OQ?
Radii of same circle, ma'am.
Yeah, radii of the same circle. And then what's the other one?
OP is equal to OP.
OP equals OP.
Yeah, OP is equal to OP, common side. So what rule does this make?
RHS.
RHS.
Angle, yeah. Hypotenuse, right angle, hypotenuse, and some side. So by RHS rule, the two triangles are congruent to each other. So what do you have from CPCT? Okay, tell me the order. Tell me how do we name the triangles in the correct order?
OTP is congruent to OQP.
OTP, triangle OTP congruent to triangle OQP. Very good. So here we see TP is equal to QP. TP is equal to QP, which means tangents from the external point P to the circle are equal. Yes, children, quickly make a note of this. So you must say given circle with center O. P is the point outside, P is a point lying outside the circle. PT and PQ are tangents from this external point to the circle. And then join OT, OQ and OP. Will not give you a long time. Write it fast. Yeah. All right, children, see the next one. Find the lengths of the sides AB and AC. We have a similar question in NCRT. The second exercise, last but one question. The last exercise, last but one question. Yeah, work this. Find the length of the sides AB and AC. Now let's do it together so that we can discuss the answer. What's the first step, children? We have some construction we need to join. Join what?
We have to join OD and OF, ma'am.
No, let us first divide the whole triangle into three smaller triangles. What do we need to do for that? We need to divide the whole.
We have to join OB and OC, ma'am.
OB, OC, then
OA and OB and OA and OC, ma'am.
okay, so we'll have to join the center O to the three vertices of the triangle. Or we need to join the center O to the three vertices of the triangle. See here, join OA, OB, OC. When we do this, we are dividing the whole triangle into three smaller triangles. Join the center to the three vertices of the triangle. Join OA, OB, and OC. Name the triangles. Name the triangles, the three smaller triangles. Please name the three
Triangle.
small.
Triangle AOB.
Yeah.
BOC and AOC, ma'am.
Correct. These are the three triangles. Which is the altitude in triangle OBC?
OE, ma'am.
But it's not 90 degrees. No, how can you say that it's the altitude? It's not perpendicular to BC. Then how do you say it's the altitude?
Ma'am, it is the radius of the circle.
Yeah, it's the radius through the point of contact. So by the theorem, OE is perpendicular to BC. It's not given, but OE is perpendicular to BC because E is the point of contact and EO is the radius through the point of contact. The radius drawn through the point of contact and the tangent are perpendicular to each other. So 90. So for this triangle OBC, we have the altitude OE. What about for the other triangles? What about for the other triangles? For OBC, we have OE altitude. What about for triangle AOC?
But AOC, OF is the altitude, ma'am, which is 8 centimeters.
Yeah, so we need to, what should we do? We need to
Join OF, ma'am.
join OF. Join OF, and for the same reason, OF is perpendicular to AC. And then what about for triangle AOB? Which is the altitude for triangle AOB? Altitude for triangle AOB?
OD, ma'am.
OD.
ma'am.
So we need to join OD. We need to join OD, radius tangent perpendicular to each other. Okay, children, all of you please find the area of the whole triangle ABC first using Heron's formula. All of you please find the area of the whole triangle using Heron's formula. Now tell me how much is BD?
14, ma'am.
14. How much is FC?
16.
16. And
16,
what about AD and AF? Are they equal, AD and AF?
Yes, ma'am.
Yes, ma'am.
Because they're tangents from the same external point A to the circle. So AD is equal to AF. Let's call them X each. So now you have the sides X plus 14, X plus 16, and 30. The sides are X plus 14, X plus 16, and 30. Please find the area of the whole triangle ABC using Heron's formula. And tell me the answer.
Ma'am,
Yeah. What's the area?
ma'am, root of 224x square plus 6720x, ma'am.
Okay. Read out what you have in the earlier step. root of after substituting root of before you multiplied.
Yes, ma'am. Root of x plus 30 into 224x, ma'am.
Correct. You can just leave it like that. Root
Yes,
of
ma'am.
x plus 30. That next step is not needed. Root of x plus 30 into, yeah, I think you got 16 x and yeah, you multiplied 16 and 14. So you have root of x plus 30 into 16 into x into 14, correct?
Yes, ma'am.
Yeah, now that 16 will come out as what? 4.
Yes, ma'am.
So it will be, and then you have 14x. So it will be 4 root of 14x plus 30. All of you must have got this. Area of triangle ABC using Heron's formula is, after substituting, the semi-perimeter is x plus 30. Semi-perimeter is x plus 30. You will get 2x. You will get semi-perimeter is equal to 2x plus 60 by 2. S is equal to 2 common x plus 30 by 2. 2 gets cancelled. S is equal to x plus 30. This is the semi-perimeter. And then S into S minus A, S minus B, S minus C. On simplifying, you should get x plus 30 into 16 into x into 14. So 16 will come out as 4. And then root of 14x into x plus 30. You can leave it like this. We don't have to multiply. You can just leave it like this. Yeah, now find the area of the find the areas of the 3 small triangles AOB, BOC, and AOC. Half base into height. Height is the radius, 8 centimeters. Half base into height. Find the area of AOB, BOC, and AOC.
Ma'am?
Yeah. Yes.
Ma'am,
Clear the
4x plus 56 only will come, ma'am.
Oh, sorry. Yeah. 14 fours are 56. No. 16 fours are 60. Yeah. 56. Yeah. Yeah. Thank you. Yeah. So you find the area of the 3 small triangles. Now add area of triangle AOB, BOC and AOC. What do you get?
8x plus 240.
8x plus 240. Correct. Now how do you proceed?
We should equate both the areas.
Correct. Area of triangle ABC is equal to the sum of the areas of the three small triangles. Correct. Very good. I'll just give you some time. I'll show you the answer. I have the complete answer working. I'll just give you some time to finish it. Please finish it and tell me the value of x. Yeah, children, what's the value of x? Yeah, children.
1 minute,
1
ma'am.
minute.
Yeah, okay. I think we are stuck somewhere. Need help?
1 minute.
Okay, okay. Oh my. 4x and 4x is 8x, sorry. So sum 120, 64, 6. 40. I need to clear the first 4 lines, children. I need to clear the first 4 lines.
Ma'am, x is 30, ma'am.
X is 30. Huh?
30. Yes,
1
ma'am.
3 1 3 or 3 0?
30, ma'am.
No. What's the other value of x you got?
Minus 12.
You gone wrong there. It's minus 30 and plus 12.
Okay, ma'am.
Please check. So on squaring both the sides, we get 16 into 14x. One minute. Before we square, I could have simplified here. Yeah, so see here, 4 1s are and 4 2s are. I could have simplified here. Yeah, now we'll square on both the sides. So you get 14x into x plus 30 is equal to 4 into x plus 30 the whole square. All of you should understand till here. We found the area of the whole triangle using Heron's formula. And then we found the areas of the 3 small triangles. And this is the equation. The area of the whole triangle is equal to the sum of the areas of the 3 small triangles. And then we substituted whatever we got. And here, you have to take out 8 common so that you can simplify. 8 common. So you have x plus 30 in the bracket. And then here we have 4. So 4 1s are, 4 2s are. Now we square on both the sides to get rid of the square root symbol. So on the left hand side, when you square, the square root symbol is eliminated. On the left hand side, the square root symbol is eliminated. So 14x into x plus 30. On the right hand side, 2 squared is 4. You'll have to square it. So 2 squared is 4 and x plus 30 the whole square. Now you can it's like you're transposing, you're bringing this here, you're bringing this here. So 4 into x plus 30 the whole square minus 14x into x plus 30 is equal to 0. So again, you find something common, right? You can divide by 2 throughout. See, you should simplify at every point. When simplification is possible, you should simplify and make the equation easier to solve. So you can divide by 2 throughout because we have 4 here and 14 here. So you can divide by 2 throughout. So that will give you 2 into x plus 30, the whole square, minus 7x into x plus 30 is equal to 0. Dividing by 2 throughout. So 2 into x plus 30 the whole square minus 7x into x plus 30 is equal to 0 by 2, which is 0. Every term in the LHS and RHS is divided by 2. Every term on the left hand side and right hand side is divided by 2. Yeah, tell me children, what after this? What should you do after this? Tell me. X plus 30 is common. X plus 30 is common. So in the bracket, you will have 2 into x plus 30 minus 7x is equal to 0. After this step, x plus 30 is common. So x plus 30 outside. X plus 30 is common. And in the bracket, you would get 2 into x plus 30. Because x plus 30 is common, right? So 2 into x plus 30 minus 7x is equal to 0. So x plus 30 into 2x plus 60 minus 7x is equal to 0. X plus 30 into 60 minus 5x is equal to 0. So on equating, x plus 30 is equal to 0, x is equal to minus 30. So this is not possible. The value of x cannot be negative. 60 minus 5x is equal to 0. 5x is equal to 60. X is equal to 12. Now that you have the value of x, you can find the length of the sides AB and AC. X plus 14 and x plus 16. So it will be 26 centimeters and 28 centimeters. I hope all of us understood the simplification part. That makes your work more easy. Wherever possible, see, the first thing is you should have taken 8 common here. That's the first thing. Here you should have taken 8 common. Only then you can cancel 4 ones are 4 twos are. That's the first thing. And here also, in the under the square root, you would have had 16. So it comes out as 4. You don't have to multiply these terms now. You don't have to multiply 14x into x plus 30 now. We'll see that later. So here 8 was common, then 4 ones are 4 twos are 8. Then we squared on both the sides. And when you square on both the sides, again, you see you can simplify. There's 4 here, there's 14 here. So you can divide by 2 throughout. And then whenever, so this term here has x plus 30. This term here also has x plus 30. There are 2 terms with x plus 30 in them. X plus 30. So x plus 30 is common. There are 2 terms. This is the first term. This is the second term. This is the first term. This is the second term. Both the terms have x plus 30 in them. So x plus 30 common. So if x plus 30 is common, then 2 into x plus 30 will come in the bracket for the first term. And for the second term, x plus 30 is outside, so minus 7x. That's all. Please complete it, all of you. Done, children?
Yes, ma'am.
Okay. All right, let's see the next one. Prove that the intercept of a tangent between two parallel tangents subtends a right angle at the center. Prove that the intercept of a tangent between two parallel tangents subtends a right angle at the center. So this one in NCERT, the figure was given and what you have to prove was also mentioned, so it was easy. Now sometimes the figure will not be given, but the description about the figure will be given to you, with the help of which you need to make out the figure. If you're not able to make out the figure, even though you knew the proof for that figure, you will not be able to crack the question because you were not able to make out the figure at all. So prove that the intercept of a tangent between two parallel tangents subtends a right angle at the center. So center meaning there's a circle. Center meaning there is a circle. Circle, center, parallel tangents, parallel tangents. Now see this, the intercept of a tangent between two parallel tangents. So there is another tangent. I'll complete it and then you can ask me if you have any questions. Intercept of a tangent, meaning there's another tangent. And this is the intercept of the tangent between the two parallel tangents. That is, intercept is that piece. This is another tangent. Okay, so see here, this is a tangent at the point A, say. This is another tangent at the point B. Now these two tangents are parallel to each other. These two tangents are parallel to each other. Now there is another tangent. There's another tangent like this, say at C. There's another tangent at C. There's another tangent at C. All right. And this is the intercept. And this is the intercept of a tangent between two parallel tangents. Please understand, two parallel tangents. This is the intercept. This is the intercept of a tangent, of another tangent between two parallel tangents. You must prove that this intercept subtends a right angle at the center. So at the center, join the ends of the intercept to the center. See, this is one end of the intercept. This is one end of the intercept, join it to the center. This is the other end of the intercept, join that also to the center. You must prove that this is 90 degrees. You must prove that this is 90. You remember the diameter was already connected there in the figure. So you need to connect this. This is the diameter. Remember, we joined this and we proved that these two triangles are congruent, these two triangles are congruent. And that way later we proved that this angle is 90 degrees. I'll just give you some time. Please refer to that proof in your notebook now. I'll tell you again. Circle, 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 center O, tangent at A, tangent at A, tangent at B. These two tangents are parallel to each other. There is another tangent. It can be on this side also. It can be on this side also. So that the figure looks familiar. I'm taking it on the same side as we see it in the NCERT textbook. So This is another tangent. Okay, at say at C. This is another tangent. This is the tangent segment or the intercept of a tangent. This is the tangent segment. From here to here is a tangent segment or the intercept of a tangent between two parallel tangents. So these are two parallel tangents. This is that intercept. This is that intercept of a tangent between two parallel tangents. It's between two parallel tangents. You must prove that this intercept subtends 90 degrees at the center. So see here, this one makes 90 degrees at the center. So join the ends of the intercept. This is one end, join it to the center. And this is the other end, join it to the center. We need to prove that this one is 90 degrees. So join AOB, that will be the diameter. That will be the diameter because I told you in the last class that when two tangents are parallel to each other, and you join their points of contact. When you join their points of contact, now when you join A and B, when you join their points of contact, A and B, AB will be the diameter to the circle. That is, AB will pass through O. Point of contact A, point of contact B. The two tangents are parallel to each other. When you join the points of contact, it will pass through O. And AB is the diameter. AB is the diameter. When we join the points of contact of two parallel tangents, that line segment will be the diameter to the circle. So prove that these two, okay, we need to join OC. Prove that these two triangles are congruent, these two triangles are congruent. And then you will get CP, CTC, this angle is equal to this angle, this one is equal to this. And like that, you proceed to prove that angle formed at the center is 90 degrees. I'll give you 3 minutes time, open your book and go through that full proof. Done, children?
Yes, ma'am.
All. All right, I hope all of you went through the proof. We did it recently in the class. So these are the, the statement will be given for this figure. Prove that the intercept of a tangent between two parallel tangents subtends a right angle at the center. Can anyone tell me the question number in NCERT? NCERT circles, question number?
9, ma'am.
9. Okay. Thank you, Tiranesh. So this is NCERT. Second exercise, question number 9. Second exercise, question number 9. All right. Yes, this one is also NCERT, children. This is also NCERT. This is, I think, example. It's one of the examples. Example 3, I think. Example 3. Example 3. Yes, this was explained in the last class or the class before that. Please try. Okay. So now tell me, how do we prove that? Now, children, one thing is I told you that for this one, you need to prove that this angle is 90 degrees. This one is 90 degrees. This angle is 90 degrees. To prove that this angle is 90 degrees, you simply have to take two triangles and show that they are congruent to each other. You may take up these two triangles. I think we did with these two triangles when we learned it here for the first time. You can also take up these two triangles. I'll repeat. We need to prove that this angle is 90 degrees. We need to prove that this angle is 90 degrees. It's not given. We'll have to prove that. To prove that this angle is 90, you can take up these two triangles, these two small triangles, these two small triangles, and show that they are congruent to each other. And then finally you get this result that this angle is 90 degrees. Or you can even take up these two triangles. This is what we did in the class when we understood this. We took up triangles ALP and BLP and we showed that they are congruent. You can also take up the triangles ALO and BLO. So for a change, let's do using these two triangles. See, but the idea is to prove that this angle is 90 degrees. Why are we showing that these two triangles are congruent? See, we want to achieve this result. This angle is 90. Even when you take up these two triangles, the goal is to prove that this angle is 90 and also to prove that AL is equal to BL. Again, you understand. AL is equal to BL. Even if you prove that these two triangles are congruent, you can get the result AL is equal to BL. Or if you prove that these two triangles are congruent, still you can get the result AL is equal to BL because their sides and both the sets of triangles. Is that fine, children? Shall we proceed?
Yes, ma'am.
Okay, thank you. So now tell me when we take up triangles ALO, triangle ALO and triangle BLO. What is that we have? What are the equalities we have?
AO is equal to BO.
A equals OB, ma'am.
One minute, Tirunesh, AL is equal to BL, is it?
And AO is equal to BO.
Oh, you said AO is equal to BO. Okay, AO is equal to BO. Yeah, Priyadarshini?
OL equals OL, ma'am. Common side.
Okay, OL is equal to OL class. I know the strength is. Oh, we are 13. There's Lakshita. Class, use the emoji, raise your hand. Priyadarshini, Tirunesh, Arnav, Shivani, Sudarshan, Shriya, Akshara, Manasa, Srinivasan, Lakshita, Muthuvel, Shruti. Nishita, are you there? Nishita? Okay, good children. So the others, please volunteer. What's the, not Tirunesh, not Priyadarshini, somebody else tell me. What's the third equality? In triangle ALO and triangle BLO, AO is equal to BO, radii. OL is equal to OL, common side. What's the third equality? Yes.
Angle ALO is equal to angle BLO 90 degree.
No, that's not given, right? Okay, what is the reason?
I'm looking from the figure and telling.
Yeah, no. Okay, correct. Correct meaning, yeah, from the figure, because it is 90 degrees, which we don't know now. The figure looks like that. It is 90. So the figure looks like that. But as of now, we don't know. We don't have that information. We need to prove it. So there is some other pair of equal angles. There is another pair of equal angles.
Ma'am, can I say?
Yes, Priyadarshini.
Yes, ma'am. Angle OAL equals angle OBL, ma'am.
OAL. But will that be useful? Correct.
Yes,
You're right. Okay, who can give the reason for that? Priyadarshini says angle OAL. OAL is equal to angle OBL. She's right. What's the reason, class? And will that information be helpful to complete that these two triangles are congruent to each other? Yes, why is OAL equal to angle OBL? Okay, Priyadarshini, you yourself tell us how is OAL
Yes, ma'am.
equal to OBL?
Because angles equal to opposite sides are equal, ma'am.
Angles opposite to equal sides.
Yes, ma'am.
Yeah, angles opposite to equal sides of a triangle are equal. So since OA is equal to OB, it's an isosceles triangle. This side is equal to this side. So she's saying this angle is equal to this angle, isosceles triangle property. But I'll tell you what we have written then. We have mentioned this side is equal to this side, radius, and then this is the common side. And then this angle is equal to this angle. That doesn't make any valid congruence rule because that is like SSA. SSA it is. That's SSA. Angle OAL is equal to angle OBL is true. But this equality will not, give us a valid congruence rule using this equality. Okay, so it is this one. So though this equality is true, we cannot use it. Okay, so it is this. Yeah, now why is this angle equal to this angle? Tell me. This is the equality which we have to take up. We need to write angle 1 is equal to angle 2. But how is angle 1 equal to angle 2? Recall children, equal tangents subtend equal angles at the center. Equal tangents subtend equal angles at the center. And if I say angle, this angle is equal to this angle, then the reason is equal tangents are equally inclined to the line segment joining the center and the external point. Angle 1, see 3 is equal to 4, we are not going to use here, we don't need it. The 3 is equal to 4 is when we take the other set of triangles. There we will be using 3 is equal to 4 to prove that the triangle is congruent. To prove that this triangle is congruent to this triangle, then we need to take 3 is equal to 4. But I'm just telling you the reasons. Angle 1 is equal to angle 2. Reason is equal tangents subtend equal angles at the center. And for 3 is equal to 4, the reason is equal tangents are equally inclined. Equal tangents are equally inclined to the line segment joining the center and the external point. You have this in your tuition notebook. Angle 1 is equal to angle 2 because equal tangents are equally Angle 1 is equal to angle 2 because equal tangents subtend or they make equal angles at the center. Angle 3 is equal to angle 4. Reason is equal tangents are equally inclined to the line segment joining the center and the external point. Now, what's the congruence rule for these two triangles? What is the rule?
SAS.
SAS. By SAS congruence criterion, the two triangles are congruent to each other. So what should you use? You must use these. You must say that OA is equal to OB. Then this is the common side and this angle is equal to this angle. If you're taking up these two triangles. If you're taking up these two triangles, then you say this side is equal to this side because tangents from an external point of the circle are equal. And then this is the common side. This is the common side. And then we say this angle is equal to this angle. Okay, because they're equally inclined to the line segment joining the center and the external point. In both the cases, the congruence rule is SAS. Okay, so coming back to these two triangles. So since these two triangles are congruent to each other, CPCTC AL is equal to BL. AL is equal to BL, CPCTC. Now you can see here AB is 16. AB is 16. AB is 16. So that means AL is 8 and BL is 8. AB is 16. That means AL is 8, BL is 8. And you're given, 1 second, we cannot use that now. Okay. So since these two triangles are congruent, AL is equal to BL, so 8 each. And then this angle is equal to this angle. These two angles are equal because CT, CTC. But their sum is 180. So each of them is 90 degrees. So you know all that. You can mark the angles 3 and 4. 3 is equal to 4, but 3 plus 4 is 180. So you get 3 is equal to 90 degrees. So like this we get, or we prove that this angle is 90 degrees by showing that these two triangles are congruent. And we get this 90 degrees plus AL is equal to BL. Is it clear, children?
Yes, ma'am.
Yes, ma'am.
Okay, so Priyadarshini and Thirunesh are helping me run my show. Thank you. And sometimes Arnav, thank you. All right, children, so you can take up these two triangles or these two triangles and show that AL is equal to BL and this angle is 90 degrees. And for congruency, you must take these two angles are equal. Or if you take up these two triangles, you must say that these two angles are equal. Only then you will get a valid congruence rule, SAS. So now you will have OA is 10 centimeters is given, AB 16. So this will be 8 and this will be 8. So using Pythagoras theorem, you find that this is how much? 6 centimeters. OL is 6 centimeters. OL is 6 centimeters. You can find OL now using Pythagoras theorem because it's the right triangle. OL is 6 centimeters. That's it. Now to find the length of PA, we need to use similarity. Take up that little triangle OLA, that small triangle OLA, and see the figure is like this, you know, there's a figure like this. I'll show you only one part of it. See here, there's A here, there's L here, there's O here, and there is P here. And there is 90 here. And there is 8 here, there is 6 here, and there is 10 here. We see that the top portion, APLO. AOLP. I hope you can see that. Now take one small triangle and the whole triangle and show that they are similar to each other. You can take, there are 3 right triangles. See, this one is also a right triangle. Which one? This is also a right triangle because this angle is 90 degrees. Radius perpendicular to tangent. This one is 90. Radius tangent perpendicular to each other. So there are 3 right triangles here. There are 3 right triangles. The small ones are OLA and OLA and what is it? PLA. OLA and PLA are the 2 small triangles, and the big one is OPA or OAP. The 2 small triangles are OLA, PLA, and the whole thing is OAP. I'm saying take one small triangle and this big triangle, the bigger one, the biggest one, this one. Take this along with this or this. Okay, so supposing you take OLA and the whole triangle OAP and the whole triangle OAP. So what do we have for similarity? What do we have for similarity? First is both are right triangles. OLA is a right triangle because it's right angle here, angle 1. And OAP is also a right triangle because it's right angle here, 2. Angle 1 is equal to angle 2, 90 degrees. And then another equality is the common angle. OLA has this angle. OAP also has the same angle, this angle. You can mark it 3. Angle 3 is equal to angle 3. Angle 3 is equal to angle 3. The two triangles have a common vertex, O. So that angle will be common. Angle 3 is equal to angle 3 because OLA, OAP, O, common vertex. Angle 3 is equal to angle 3. And then both are right triangles. So angle 1 is equal to angle 2. So now they're similar. How do you name the triangles? The common vertex is O. The vertex with the right angle is L. And the third vertex is A. Similarly, for the big triangle, the common vertex is O. A is the right angle. The third vertex is P. OLA is similar to OAP. So now in similar triangles, corresponding sides are proportional. What am I writing? OL by OA is equal to LA by AP is equal to, let me write it neatly. So from this we have OL by OA is equal to LA by AP is equal to OA by OP. That's it, children. Just substitute the values. What is OL? How much is OL? OL is 6 by Pythagoras theorem. OL is 6. OA is 10. LA is 8. AP is what we have to find. AP. So this is enough. You can cross multiply and find. 80 by 6. 40 by 3. 40 by 3 centimeters. All of you got it? Important question. Is it understood, children?
Yes, ma'am.
Okay. You're still writing. I'll just wait for some more time. All right. Try this one, children. What's your next question? Yes, I hope you're working. All right. Yeah, tell me. Children, so let's start with the first one. On the left hand side, we have AB plus CQ is equal to. Now, what is AB plus CQ equal to? What is AB? AB can be written as AP plus BP plus CQ. CQ can be written as CR. Just change everything. Just change everything. AB can be written as AP plus BP. Is that correct?
Yes, ma'am.
Yes.
Okay. And CQ can be written as CR, right?
Lengths of tangents are equal, ma'am.
Correct. Length of tangent from the same external point to the circle are equal. CQ is equal to CR. I'll write it again. So I'm taking the left hand side. This one, AB plus CQ. Okay, so AB plus CQ is equal to, what is AB? AB is nothing but AP plus BP. AP plus BP plus CQ is nothing but CR. Now, how do you get AC? See the right hand side. Right hand side, you should get AC. AC plus BQ. On the right hand side, please see, you should get AC plus BQ. What will give you AC? AR plus CR. And we have AR plus CR here. Do we have AR plus CR here? Children, only if you say it's easy to understand. See here, let me start again. AB plus CQ. Please tell me. If you've written it, don't rub it. I'm writing the same thing again. We're going to write the same thing again, so don't erase anything from your book. Yes, children, please tell me what is AB?
AP plus BP, ma'am.
AP plus BP. Okay. Plus what is CQ?
CR, ma'am.
Okay, this is one part. Now, what I'm saying is on the other side, we have AC plus BQ. What will give us AC? What will give us AC? AR plus CR. AR plus CR. Do we have AR here? We have CR. Do we have AR?
No, ma'am.
But what should be substituted with AR?
AP can be substituted.
AP, because AP is equal to AR. So in the next step, you write AP is AR. And the CR, AR and CR together. AP, write it as AR because AP is equal to AR. And CR, because combining these two only you can get AC plus BP. But what should you actually have on the other side? BQ, right? But BP is equal to BQ. AR plus CR is AC plus BP is nothing but BQ. So we got the result. AB plus CQ is equal to AC plus BQ. See how to change, why to change, that is very situational. We start with the left hand side where we have AB plus CQ. And this is what is possible to do. AB can be split as AP plus BP. And CQ can be replaced with CR. This is the change you can do. And you should write CQ as CR because CR is on AC, right? CR is on AC. You want to get AC in the right hand side. So let it be like this. Now you know that AC is AR plus CR. So you take away AP and you write AR. Because they're equal, tangents from the external point A to the circle are equal. Plus CR. And say we don't know that we have to change BP. So if you write it as it is, next step AR plus CR is AC. Plus BP you have. BP, but it's BQ. So you can write BP as BQ. Tangents from the external point B to the circle are equal. Hence proof. AB plus CQ is equal to AC plus BQ. Isn't it simple, children?
Yes,
Isn't it
ma'am.
simple, children?
Yes.
Yes.
Yeah, that's about the first part. Very good. Write on. You must give reasons. When you write AR is equal to AP is equal to AR, you must write tangents from in the bracket at the end. You should write AR is equal to BR because tangents from the same external point A to the circle are equal. Okay. Next, second part. Area of triangle ABC is equal to something we need to get half perimeter of triangle ABC into R. So let's work the area of triangle ABC. How do you find area of triangle ABC? Area of triangle ABC is equal to, as we always do, we join this, we join this, we join this, we get the altitude, 90, 90, and 90 here. So this is the radius, this is the radius. So area of triangle ABC is equal to area of triangle this is the second subdivision, area of triangle ABC is equal to area of triangle AOB plus area of triangle BOC plus area of triangle AOC. So area of triangle ABC is equal to area of triangle AOB, that is half into AB into R plus BOC, half into base BC into R plus AOC, half into base AC into R, radius. Height is the radius. Altitude is the radius. So this will give us, in all the brackets, children, you can see that R by 2 is common. Can we see that? Half R. Okay, let me say half R is common. In all the three brackets, half R is common. Yes or no, children?
Yes.
Yes,
Now,
ma'am.
what will I get inside the bracket? If you take out half R common, what will you get inside the bracket?
AB plus BC plus
AB
A.
plus BC plus AC.
And what is AB plus BC plus AC?
Perimeter of triangle.
Perimeter of triangle ABC.
Perimeter of triangle ABC. This is the proof. Please write down, children. So we proved that area of triangle ABC is equal to half R into perimeter of triangle ABC. Or whatever, half perimeter of triangle ABC into R. Please write. I'll just be back, children. I didn't ask you. I didn't take your permission. Is this over, children?
Yes, ma'am.
Yes.
Yeah, children. This is the next one. This also we have done it in the class. Find the radius of the circle. So here what you have to do is you have to join OS and OR and prove that OSDR is a square. There's a right angle given here. There's a right angle given here. Okay, so join OS and OR and prove that OSDR is a square. Yes, children. So first step, join OS, OR. Okay. Join OS, join OR. Now, how will you show that OSDR is a square?
OR equals OS.
Okay, since we just have 5 minutes left, let me just prompt so that you can complete it. Is this angle 90 degrees? Yes, you're right, Priyadarshini. OR is equal to OS, you're right. Let me just prompt and you will give me the reason. Is this angle 90 degrees?
Yes, ma'am.
Why?
Radius and tangent are perpendicular.
Yes.
Yeah, okay. Is this angle 90 degrees?
Yes, ma'am.
Yes, ma'am.
Okay. Then in this quadrilateral, 3 angles are right angles. Then what will be the measure of the 4th angle?
90 degrees.
90 degrees. So see, one of the angles is 90 is given to us. This is 90 because radius perpendicular to tangent. This is 90 because radius perpendicular to tangent. OS is the radius and AD is the tangent. And in the quadrilateral, since one angle 90, second angle 90, third angle 90. So the 4th angle also has to be 90 degrees. So what do you call a quadrilateral in which every corner is a right angle? What do you call that? What do you call a quadrilateral wherein all
Rectangle or square.
rectangle or a square? It's a rectangle or a square. A quadrilateral in which each angle is a right angle is a rectangle. But you cannot say it's a square. It is definitely a rectangle. But you cannot say it's definitely a square. You will have to prove it's a square. If you want to say it's a square, you will have to show that it's a square. But when there is no choice, it has to be a rectangle. If every angle is a right angle, it is a rectangle. It is a rectangle. But you cannot say it is a square. You have to prove it's a square. We know that in a square also each angle is 90 degrees. But you'll have to prove it's a square by saying that all the sides are equal. And again, you know that in a rectangle, opposite sides are equal. So it's enough you prove that adjacent sides are equal to show that all the sides are equal. Now we have to take Priyadarshini's point. OS is equal to OR. Correct?
Yes, ma'am.
OSDR is a rectangle. But you can say DR is equal to DS, or you can say one of these two. You can say DR is equal to DS because DR and DS are tangents from the external point D to the circle. So you can say adjacent sides dr is equal to ds, or you can say OS is equal to OR, radii. Any one of the two you can mention. So dr is equal to ds, meaning adjacent sides are equal. Already opposite sides are equal. Now when adjacent sides are equal, that means all the sides are equal. So OSDR is a square. But ds is equal to dr is equal to ds. So this implies OSDR is a square. See, children, already we have OS is equal to dr because rectangle opposite sides are equal. OS is equal to dr and ds is equal to OR. We already have OS is equal to dr and OR is equal to ds because it's a rectangle. Now we have dr is equal to ds. See here, dr is here, ds is here. Dr is equal to ds. That means all are equal. All these are equal. That is why when opposite sides are equal and one pair of adjacent sides are equal, all the sides become equal. Opposite sides are equal. OS is equal to dr because rectangle. OR is equal to ds. Rectangle, opposite sides are equal. But dr is equal to ds. Dr is equal to ds. See, dr is equal to ds. These two are equal and these two are equal. And if these two become equal, that means all are equal. That's why it's a square. Now, children, tell me, how do we proceed? How much is BP, children?
27.
27. This one is 27. And CD?
25.
25. And BC?
38.
38. Now, we need to know a piece like this. If you know the full thing, nothing can be done. We need to know a piece like this. So let's start from BP. Let's start from BP. If BP is 27, how much is BQ?
27.
27. Why?
27.
Because BP is equal to BQ. BP is equal to BQ. Then how much is CQ?
11,
11.
ma'am.
11. Then how much is CR?
11, ma'am.
11. Then how much is DR?
14, ma'am.
14. But OSDR is a square. That means all the sides are equal. Then how much is OR? If DR is 14, how much is OR?
14, ma'am.
14. That means the radius is 14. So the radius of the circle is 14 centimeters. The radius of the circle is 14 centimeters. So first, step 1, you need to prove that OSDR is a square. You have the construction and all that, join OS, join OR. Show it's a square. That's the first step. Show that OSDR is a square. After that, start from that little, meaning that you know, like BC, CD are full sides, BC and CD. Given that 25 and 38 are full sides of the quadrilateral. Take this small piece BP. It's not AB, no, it's just BP, part of AB. Start from there. Start from there. BP is 27. That means BQ is 27. So 38 minus 27 is 11. 11 is the remaining part. This is 11. If this is 11, CR is 11. But the whole thing is 25. So 25 minus 11 will be 14 here, DR. So first step, prove that this one is a square. This is square. This one is 27. So this is also 20. This one is also 27 because BP is equal to BQ. But the full thing, CD is, but the full, oh, sorry, not 27. Yeah, it is 27. But the full thing is 38. BC is 38. The full thing is 38 and this portion is 27. So the rest of it will be 38 minus 27. 38 minus 27, this is 11. If CQ is 11, CR is 11. But CD is 25. This full thing is 25. So this one will be 25 minus 11. 14. But it's a square, all the sides are equal. This is a square, all sides are equal. All sides are 14. That means OR is 14. So the radius of the circle is 14 centimeters. All right, children, we'll just wind up our session with this one. Yeah, please tell me the value of A and B, children. What's the value of A? A is a very obvious thing, no? What's the value of A?
35 degree, ma'am.
35 degrees. Yeah, because equal tangents are equally inclined to the line segment joining the center and the external point. This angle is equal to this angle because this is the line segment joining the center and the external point. See, this is the line segment joining the center and the external point. These are the tangents. These are the tangents. These two angles will be equal. These are the inclinations. Equal tangents are equally inclined to the line segment joining the center and the external point. A is 35 degrees. You can just state that theorem and write A is equal to 35 degrees. What's the value of B?
55 degree.
55 degrees, ma'am.
Yeah. How do we find that? What's the measure of OQP? This is 90,
90
right? Sorry, this is 90. So by using angle sum property in triangle OQP, angle Q is 90 degrees. So in OQP, by using angle sum property, we find B is equal to 55 degrees. 90 degrees plus 35 degrees plus B is equal to 180. So on working that, you will get B is equal to 55 degrees. $55 or $45, children?
$55.
55 only, ma'am.
Oh, yeah, 55, yeah. Suddenly a mind block, you know. Oh, yeah, 55, yeah. Suddenly I was seeing 90 as 100 degrees and I'm like, why everybody is telling 55 and yeah, right. Yeah, so B is 55 degrees. All right, children. Please take a shot. I'll show you the question paper first, 1 minute. Just a second. Okay, I hope you have the questions. Take a screenshot of the answers, children. We already discussed the answers. Still, if you could not complete it, take a screenshot. it fine, children? All right, so that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you.
Thank you.
Thank you. Good night.
Thank you, ma'am.
Thank you, children. Good night.